I am Victor Muñoz. I am full professor of Engineering System and Automation, and I teach in automation as well as robotics. And this lesson is about how can you use digital twin technologies in theorems. How can you use this technology in order to reach the scheme of Turing's 4.0. The digitalization of the Turing sector means to include the digital technology in each step of the touristic business. That's it. We have to provide to the client services like online reservation, digital marketing, platform for destiny recommendation, travel management, as well as electronic payment. For making this through these services, we have to use the social network and using social medias, emphasizing the mobile connectivity in order that the client can consult their travel by using mobile phones, tablet, a computer, and so on. It's necessary to optimizing the website to provide safety for electronic payment, to offer new services, as well to integrate digital tools in the business in order to make all the transactions inside of the company electronically. Of course, it's necessary to use a big data analysis in order to provide a travel recommendation and know the profile of each client, and put in operation online sales channels in order to make it more easier to buy travel and design the required travel to the client. The term Turing's 4.0 it is inspired on Industry 4.0, and this means to include in the Turing sector, in the tourist business, include the technologies related with Industry 4.0. This want to reach more digitalization and interconnection between the different steps of the Turing's business. This scheme shows the fourth industrial revolution, which started at the 18th century, where the machine used the steam power in order to the automation of industrial processes. Then, at the end of the 18th century, the automation used electrical energy, and Henry Ford introduced the mass production and assembly online in order to produce his famous 40 vehicle. Then, in the 80s of the last century, to the automation process was include robots, a computer, and electronics. Then will provide a more flexible production lines and the ability to produce several kinds of products in the same production line. And nowadays include to the concept of the Industry 3.0 will include the connectivity. In this way, the robots and automation system are connected by Internet of the Things, use cloud computing, artificial intelligence, and all the new technologies. This look for to integrate all the production process in a company from the production to the relationship with the customers. This scheme shows the enabled technology for Industry 4.0. I will start detailing additive manufacturing. That means 3D printer in order to making rapid prototyping of the products. The use of cobots that are robots that make collaborative tasks with humans. Also the augmented reality in order to explore virtual scenarios in the production line. And we use machine learning for developing algorithms for prediction, optimization of the production process. all the elements in Industry 4.0 are connected via Internet of the Things, that is a communication system. Use big data in order to look for patterns and figure out what is the tendency of the market, and a real-time optimization of the process, and big servers that provide cloud computing. And the lection of today is based on physical systems that we can look for what is the connection of this technology with Turing. Because of this technology is marked by a red circle in order to speak in detail about this technology of cyber physical systems. This scheme shows the structure of a cyber physical system. In the left, you can see the user that have an interface in order to interact with the cyber physical system. This interface have three modules. The first one is the decision support, the second one is user commands, and the third is the 3D dynamic simulation. Then, by using this interface, the user communicates with a real system that can be a production line and introduce to the real system actual process input data. This system have a behavior and produce the output data that will be used by the digital twin. The digital twin is the green box and is the virtual or digital representation or modeling of the real system. Then the digital twin use the output data of the real system as well as the input data of this real system in order to produce two output. The first one is service data that will be used for decision support, and the other one is for the virtual interaction and represent the digital version of the real system in a 3D works by using the 3D dynamic simulation. Now, after this general structure of the cyber physical system, we will focus on the digital twin. This is the internal architecture of a digital twin that I showed you in the previous slides, where the digital twin is together with a real system. Then you can see in this structure that we have the input data of the real process, the output data of the real process, and the exit of this digital twin is the virtual interaction service data, as I showed you in the previous scheme. Inside of the digital twin there are three components. The first one on your left are the models of the real system. That is the real digital twin of the physical elements of the system that we want to represent. These physical elements are modeled by two models. The first one is 3D geometrical models in order to represent the real system in a virtual world, and the second one is the dynamic models, that is the behavior of the real system. Then these two models produce virtual data that are stored in a database, where in the same database are stored the actual output data of the process. This pair of data, virtual and actual data of the process, are used by the service model in order to make predictions, fault tolerance detection of optimization of the process. This is the general architecture of the digital twin, and because it's so general, after this slide I will show to you an example of a real system that use a cyber physical approach with a digital twin. This is real car, and we'll use this example in order to explain to you what is the cyber physical system and what is the digital twin by using this car. In the next slide, we can study step by step the components of the digital twin and how to include this digital twin in a cyber physical system. First, we consider the models of the digital twin, and in this slide I show to you the 3D geometrical model of the car. As you see, it's a set of polygons, plots, surfaces that model the physical appearance of the car, is the shape of the car. This model will be used in order to represent the car in a virtual world. In order to show to you the electric car dynamic model, I consider this simple example, where the car is composed of the batteries, the accelerator pedal control, and the engine. In this way, the driver, by using the accelerator pedal, provides to the engine more energy that produces an advanced force F. Against this force F are the aerodynamic force, the inertia force, and the friction force. These forces decrease the speed of the car. In this way, the actual vehicle speed x dot is the balance between the engine force and the aerodynamic force, inertia force, and friction force. Then, by using a methodology based on the balance of the force, the advanced force, and the force against the movement of the car, we compute the dynamic model of the car. That is an expression about the acceleration. The acceleration depends on several things, including the mass of the car and the forces against the movement of the car. Will be use this formula in order to simulate the dynamic behavior of the car, and will be included inside of the digital twins. This slide shows to you the particular digital twin of the car with the consideration that I said to you in the previous slides. In this way, in the left are the 3D geometrical model of the car. Below this model is the dynamic model of the car, and both together produce the virtual speed by using the dynamic model of the car. This virtual speed is mixed with the actual of the speed of the car in the speed digital twin database, and these data are used for by the service model. In this case, the service model are devoted in order to compute the road slope of the car. Then, if the actual speed is greater than the virtual speed, then is a down ramp. If the actual speed is minor than a virtual speed, then is upward ramp. And if the actual speed is equal to the virtual speed, then is a flat road. Then the exit of the service model is the road slope, as well as the virtual reality of the car that will be used in order to simulate the car in the virtual world. By considering the detailed twin of the car that I explained to you in the previous slides, this is the structure of the cyber physical system of the electric car. In this way, the digital twin is in the green box, and in the middle of the slide is the real car. The real car, when the driver commands a pedal angle, the engine produces a force, and this force produces the actual speed of the car. This actual speed of the car and the engine force feed the electrical car digital twin in order to produce the two exits. The first one is the road slope, as I said to you previously. then say to the driver a recommended speed. The second one is the virtual reality information that will be used by a 3D car representation in a virtual world. In this way, this example shows to you with a specific case what is a cyber physical system and what is a electrical digital twin in this example. Now the question is how can help the digital twin technologies to theorems, how to apply this technology to theorems. And I found papers about the use only the 3D representation of a real thing, a real building, a real ruin, and other application that use the digital twin as I showed to you. In other words, use the digital twin by using the dynamic model, 3D model, database, and a service model, all the things together. In the next slide, I will show to you several samples how the digital twins are used in theorems. This work is focused on the construction of the 3D model of the digital twin. Only consider this component of the digital twin. In this way, this work uses drones and other measurement techniques in order to build the 3D model of ancient Roman ruins. The goal of this work is to use this model for study the ancient architecture of the Roman ruins, as well as used for virtual tours of the ruins, and study the original appearance of this ruin. In this way, as I said before, this work only use the 3D model of the digital twin and forget the database service model of the dynamic behavior of the model, because in this case have no sense these last components. This second work, as the previous one, only use the 3D information of the digital twin. In this case, is used for augmented reality. This work make an application based on augmented reality that show to you the previous appearance of several buildings in Macedonia in the period of its civil war. In this case, the building have a QR code. If you point your mobile phone to this QR code, show to you a video and audio explain the story of the building. For making this, they use several technologies. The first one is Unity, in order to develop the 3D world. Use Vuforia as well as MRTK in order to produce the 3D components and behaviors, and Visual Studio for coding the application. The application tested was made by using a Microsoft HoloLens tool in order to mix the real images and the virtual images in the glasses, and show to you the story of several buildings in a route of 11 kilometers in the area of Macedonia in Greece. The previous two works are only based on the use of 3D information for representing buildings or ruins. This work is an step beyond of this. In this way, they include the real object as digital twins with the user as avatars in a metaverse. These metaverse are used in order that the user, by using their avatars, interact with the digital twins. For this aim, there are works that use this metaverse for tourist promotion. In the right of these slides, is the development of metaverse platform for tourist promotion in Apulia, in Italy, and in the photograph you see the real place, Piazza of Ferrace, and the digital model. In this model is not only for see the model, you can interact with the model and, for example, buy touristic guides or program your travel. In this way, with metaverse, is a step beyond of only use the digital 3D information, and this step beyond is for you can interact with the digital work with your avatar in order to make things like shopping or get tourist guides or touristic travel around this place. This paper is a step forward of the previous work. Science create a virtual trade center where the companies of the tourism sector can establish a virtual office as well as the council in order to promote the tourism in the city of Valencia. The users, by using their avatar, can move in every corner of this virtual trade center as well as interact with the different offices for get tourist guides or to buy a travel or to book an hotel. In the last two examples, the metaverse was used only for tourism promotion by recreating a virtual trade center or a real place in Italy. Now the metaverse is used for education. The idea is use this virtual tool in order to promote the sustainability in tourism. The tourist, by using his or her avatar, will be the player in a virtual world that teach to he or her the rules for sustainability during their tourism activity. The world said that if we use immersive stories about ecology, it's possible that the tourists have pro-environmental attitudes, for example, to use the less contaminant transport or to know the regulation of the country about the ecology. In this way, the aim of this work is to promote the regenerative tourism, where the tourists have in their mind the rules of the ecology of the country that they will to visit. The previous works only use the digital component of a digital twin for create a virtual trade center, for create a 3D representation of ancient ruin, and just it. Now this work use all the components of the digital twin. That's it. The model, dynamic model, use the service model and include the database of the data. And this digital twin is connected with the real system. This work show to you a hotel that the aim of this work is to control the temperature and humidity of the chambers of the hotel in order to save energy. In this way, the authors in the first place model a single chamber and create the building as the composition of all the chambers of the hotel. These chambers have a dynamic model that produce the big virtual temperature and virtual humidity by using a virtual energy, and is store this information as virtual signals in the database. On the other hand, the real system, that is the real hotel, have a set of sensors that transmit the information, the real information, the actual signals to the database, and a service model use this information, the virtual signals and the actual signals, for considering the best temperature and humidity for keep the comfortability of all the chambers of the hotel. The idea is to decrease the carbon footprint of this hotel in the environment. This last example of the use of digital twin is focused on the sustainability like the previous one. In this way, use all the components of the digital twin, the models, the database, and the service model. In this example, the work is focused on the preservation of the San Juan del Hospital building in Valencia, Spain, by controlling the numbers of visitors inside this building. In this way, there are cameras that counter the people that will visit the building and scheduling these people between the different chambers. The thing is that each chambers have not to exceed the maximum visitors, because the CO2 expelled by the people can deteriorate the inner of this building. Then the use of digital twin is based of control the CO2 inside the building in order to make a preservation of the building and avoid the deterioration of all the inner of the buildings. With this last word, we finish the use of digital twin in theorems, and now the next slide is devoted to the conclusions. In this way, this lesson was summarized in this set of conclusions. The first one is the Tourism 4.0 use enables technology related with Industry 4.0. This presentation was focused how can we use a cyber physical system in theorems. In this way, a digital twin represents the shape and behavior of a physical object in a computer, and is composed of a dynamical model, a geometrical model, and a database and service models. It can be connected with the real system in order to compose the cyber physical systems. The application to the theorems that we show you in the papers included in this presentation are 3D reconstruction of heritage places or museum for virtual tourism, metaverse platform for virtual touristic services or responsible tourism, energy efficient hotel for neutral carbon footprint, or the conservation of heritage via a smart distribution of visitor, that is named preventive conservation. And with this conclusion, thank you for your attention. I hope that you understand this little presentation. Was very difficult because my specialty is robotics and digital twin and not theorems, and to explain of this paper and relate this work with digital twin was so difficult. If you have some doubt, you have here this slide my contact, email and address, and I belong to the Institute of Investigation of Cyber Physical System of the University of Malaga. Thank you very much, and I hope that you enjoyed this presentation.